Hello everyone, today we are going to talk about quadratic functions. Now in my opinion, this is a very fun topic, although some people do get quite confused. As long as you follow the steps I'm about to lay out for you, you will be able to answer any question about this topic easily. Now, today we will cover three things. First of all, what is a quadratic function? Secondly, how do you interpret a quadratic function? And thirdly, how do you draw a quadratic function? 2 and 3, we will sort of do it together at the same time because they sort of involve the same steps. Now, what is a quadratic function? Let's start by asking what a linear function is. Now, so far, you guys have been doing a lot of linear functions. Linear functions are functions where the power of x is usually just 1. For example, like this, right? The x here has only a power of 1. And therefore, the graph will always look something like this, i.e. a straight line, or like this, or like this, or like this. There's a different kind of function known as quadratic functions. These are functions where the function contains an x value which has a power of square. So this is an example, x squared plus 2x minus 1. The general equation is also known as ax squared plus bx plus c. And your a cannot be equal to 0. A cannot be equal to 0. There must be an a value, i.e. there must be some sort of coefficient for your x squared. B and c can be 0, no problem. That will still result in a quadratic function. So for quadratic functions, the graph actually looks like a simple curve, like this, or like this. Now, of course, it looks much prettier than this, but I'm just unable to draw it nicely. You might be wondering, what is the value of knowing quadratic functions? Like, how will we ever use this in real life? Well, a very good example is badminton. In badminton, a lot of the shots made actually make the shuttlecock travel in a path that is similar to a quadratic function curve. See, like imagine the shuttlecock going up and coming back down. Here, you will see that Li Zijia skillfully wins the point by accurately calculating the trajectory of a shuttlecock using quadratic functions. Beautifully done. Now, we are going to learn how to analyze and draw our own quadratic functions by following these 5 simple steps. The first step is to determine the shape of the graph by looking at the value of a. Now, the shape of the graph might be like this or like this. The second thing to do is see how the graph intersects with the x-axis by looking for the value of b squared minus 4ac. So we want to know if the graph ultimately cuts the x-axis like this, or if it doesn't even touch the x-axis at all. The third step is to determine the minimum or maximum point of the graph. Note that we're not sure if it's the minimum or maximum because this depends on whether or not the graph is like this or it's like this. The next step is to find the x-intercept. And the x-intercept is essentially the points at which the graph intersects the x-axis. And the last step is to find the y-intercept. And the y-intercept is the point at which the graph intersects the y-axis. Okay, without further ado, let's get started. So, the first step is to determine the shape of the graph. This is very simple. All you have to do is look at the a value, i.e. the coefficient of the x squared. If the coefficient of the x squared a is more than 0, then the curve will look something like this. If the coefficient of x squared, i.e. a, is less than 0, then the graph will look like this. A simple way to remember this is to think that as a is more than 0, a is positive. And when you're positive, you smile, right? So a smiley face looks like this, like a U curve. On the other hand, when a is less than 0, this means a is negative. And when you're negative, you frown and you're sad, and therefore your graph will look like a frowny face, like that. So here on the first graph, let's say we have fx equals to 2x squared plus x minus 1. You know that your graph, because a, which is 2, is more than 0, therefore your graph will look something like this. You don't know where this graph will be, but you know this is the rough shape. Whereas if you have fx equals negative 3x squared plus 2x minus 1, given that a is equals to negative 3 and that is less than 0, you know that your graph would be something like this. Simple enough. The next step is to figure out how the graph intersects with the x-axis. Now there are three possible options, and essentially the first thing you have to do is find the value of b squared minus 4ac. Depending on what this value is, your graph will intersect the x-axis differently. So in the first example, if b squared minus 4ac equals to 0, therefore your graph will intersect the axis at one point, i.e. it touches the graph, or it touches the x-axis at one single point. If, on the other hand, b squared minus 4ac is more than 0, you will know that your graph intersects the x-axis at 2 points. However, if b squared minus 4ac is less than 0, then you know that your graph does not even touch the x-axis at all. The same is true if your graph is the other way around, i.e. if it's in this shape. So for b squared minus 4ac equals to 0, the graph would look like that. For b squared minus 4ac is more than 0, your graph will look like this. For b squared minus 4ac less than 0, your graph will look like this. So for a simple example, below we have an equation, fx equals 2x squared minus 3x minus 2. All we have to do is find b squared minus 4ac, subbing the values in. b is negative 3, a is 2, c is negative 2. And remember, the negative values are also very important. If c is a negative value, be sure to import the negative value in. If not, your answer will be different. And here, this calculates to something like 25, I believe. And therefore, this is more than 0. And you therefore know that your graph intersects the x-axis at 2 different points, i.e. it looks something like that. The next step is to determine the minimum or maximum point of our graph. And the way to do this is to use the complete the square method, which is where we take the quadratic function and we turn it into this function. And this function will tell us the new values of h and k. And from here, we will know that the maximum or minimum point will have coordinates of h and k. For a detailed tutorial of how to use the complete the square method, do check out our previous video on quadratic equations, where Hazel thoroughly and clearly explains how to complete the square. Here, I'm just going to run through it very quickly. So now let's start with a simple example of fx equals negative 2x squared minus 8x plus 8. To complete the square, the first step is to take the a out of the equation, which is negative 2 in this case. Therefore, you're left with x squared. The other values will also have to be divided by negative 2. So negative 8 divided by negative 2 is plus 4x. Positive 8 divided by negative 2 is minus 4. You're left with that. The next step is to then take this value, i.e. the coefficient of x, and divide it by 2, and then square it. Sorry, I forgot plus here. And you minus that same value, and you write the remaining numbers. The next step is then to sort of combine this and this into one bracket, which can be written as such. And then you open the rest of this. It becomes negative 4 minus 4. And what you're going to do is you're going to take these two things out by multiplying it by negative 2. So it looks something like this. Minus 4 equals to minus 8. And that multiplied by negative 2 is something like plus 16. Therefore, there you have it. From here, you know that your maximum point, and we know it's a maximum point and not a minimum point, because our a is negative 2. Given that a is negative 2, that means the graph will look something like this, and therefore it has a maximum point and not a minimum point. Therefore, the maximum point is -2, 16. Note that whatever is in here, it will have to be multiplied by -1, i.e. if it's a positive, it must turn into a negative. If here is a negative, it will be a positive value. Therefore, this is our maximum point, and we can sort of know that our graph will look something like this. So -2, 16 would be somewhere here, and therefore your graph will be something like that. Right? I'm sorry for the hideous graph, but you will know that the maximum point is somewhere here. Now, this next step is something very simple. All we are trying to do is to find the x-intercept. And the x-intercept is essentially the point at which the graph sort of intersects the x-axis. Right? We want to know these 2 points. And these 2 points are essentially where fx equals to 0. Therefore, all we have to do is let fx equals to 0, and we find x from there. So taking this function as an example, we let -x squared plus 4x minus 2 equal to 0, and this is where we solve for quadratic equations, which is something that Hazel has taught you in a previous video. So do please check up on that if you're unsure as to how to solve quadratic equations. So here, I'll go through it very quickly. I'm going to use the fastest method, which is to use the quadratic formula. And this will give us x equals -b plus or minus square root of b squared minus 4ac over 2a. And this will give us 2 values, x equals 0.6 or x equals 3.4. Therefore, we know that there are 2 points here, 0.6, 3.4, and we know that the graph will definitely intersect these 2 points like this. By the way, I'm drawing a graph like this because a is negative. Negative means you're frowning, and that's why your graph looks like a frowning face. The final step is the simplest one of all. We want to look for the y-intercept, which is essentially the point at which the graph intersects the y-axis. And therefore, this is the point at which x equals to 0. So it's very simple. All we have to do is let x equals to 0. And we're left with -2. And therefore, we know that our y-intercept is -2. It will be somewhere here. And therefore, given that this is a -a value, we know it's going to look like a frowny face, so we know the graph looks something like this. Also note that there's a shortcut in most cases. Most of the time you will know the value of your y-intercept by just looking at the c value. Here the c value is -2, and that's why this is our y-intercept. Now let us put everything we've learned together and draw a graph by following the 5 steps we've just discussed. So let's take this simple function and let's draw the graph. The first step is to determine the shape. And given that a equals to 2, which is more than 0, it's a positive value, and therefore our graph should look like you guessed it, a smiley face. That's step 1 complete. Very simple. The second step is to determine b squared minus 4ac, and we just sub all these values in. b is 4, a is 2, c is -16, and therefore you have something like b squared minus 4 to -16. And note here, I'm not going to calculate this out because I'm really lazy. However, a smart way to look at this would be to know that negative times negative will be a positive, and therefore a positive plus a positive will always be, you guessed it, positive, and therefore this will be more than 0. And therefore you know that your graph will intersect the x-axis at 2 points. The next step is to determine the minimum or maximum point by completing the square. And the first step is to take the 2 out. and then you're going to combine those two values together, and you're going to be left with this, and essentially you're going to get something like this. Therefore, you know that your maximum point, I'm sorry, not the maximum point, we know it's a minimum point from the previous information. We know that our graph will have a minimum point of -1, -18. Now, for the next step, we have to solve for the x-intercept, which is we let fx equals 0, so 2x squared plus 4x minus 16 equals 0. And to solve this, I'm just going to use the quadratic equation, which will give us -b plus or minus b squared minus 4ac over 2. And this will give us two values, which are 2 and -4. And therefore, we sort of know that our equation will intersect the line here and somewhere here. So it will look something like this, right? And the final step is to essentially solve for the y-intercept, which is where we let x equals 0. So f0 equals to 2 squared plus 4 minus 16 and equals to -16. And so we know that the graph cuts across the y-axis very low down the graph at -16. So now let us look at all the information we have and use that information to plot out the graph. So what information do we have so far? We know a is more than 0, and therefore the graph looks like this. We know that b squared minus 4ac is also more than 0. Therefore, we know the graph cuts across the x-axis at 2 points. We also know that the minimum point has coordinates of -1, -18. We also know that the x-intercept, i.e. the point at which the graph intersects the x-axis, is -4 and 2. And we know that the y-intercept is equal to -16. So let's first try to draw the graph. Note that I sort of know that I have a very low y-intercept, i.e. I know that my graph will go very far down. Therefore, when I'm plotting my graph, I make sure to include enough space at the bottom of the graph. Now, the first thing I like to do is to always sort of mark the points that I know. So let's start with the minimum point. The minimum point would be somewhere around here, right? So let's just mark a point there. And let me just extend this graph a bit more, right? And so we know this is -18 and this is -1. The next thing we know is the x-intercept, which is -4 and 2. And therefore, let's put -4 here. And maybe, well, it's not very proportionate, but let's just say -2. Let's say 2 is here. And we know the y-intercept is -16. So let's put -16 here. And therefore, it becomes very easy to draw because I know that my curve will have to pass through here, get to the minimum point, cut through the -16, and go up here. And I apologize again, it's a very ugly graph, but I'm sure you get the gist. And in the exams, it doesn't really matter if your graph is ugly, as long as you sort of get the points correct, and your shape of the graph is generally correct. And that's how you draw a simple quadratic function, guys. Very simple. For a complete understanding of quadratic functions, do watch our previous videos on this topic. Thank you again for watching, and I'll see you guys again next time.